This is a video lecture on phase lock loop which is available in IC 565. Phase lock loop is a control system that generates an output signal whose frequency is related to the frequency of input signal. That is, any change in frequency of input signal reflects change in frequency of output signal. Phase lock loop consists of phase detector, active low pass filter, and a voltage controlled oscillator. In our previous video lecture, we have seen about voltage controlled oscillator. Voltage controlled oscillator produces an output signal corresponding to the input voltage provided at the pin number 5 of VCO. Let us consider output signal voltage is V0 and frequency is F0. This signal is given as input to phase detector, where output of VCO is compared with the input signal and an error signal is generated. Phase detector basically is a multiplier where multiplication of two signals takes place and results in two frequency components. One is higher frequency component, that is F in plus F naught. Second one is lower frequency component, that is F in minus F naught. And this error signal is fed as input to low pass filter. Low pass filter will attenuate high frequency components and will allow low frequency components. Therefore, F in plus F naught frequency component is attenuated and F in minus F naught low frequency component is allowed to pass through low pass filter. By attenuating high frequency, we attenuate noise present in the signal. Now low frequency component, low frequency signal is given as input to VCO. VCO will produce output signal corresponding to this particular voltage. Now, frequency of this output signal is shifted towards F in. This signal is given as input to phase detector. Again, in second iteration, signal is compared with input signal, error signal is produced, it is passed through low pass filter to attenuate high frequency components and signal is applied to VCO where it produces output signal whose frequency is now little more shifted towards F in. This will go on happen until F naught is equal to F in. So this phase is called as captured phase where F naught frequency tries to capture F in frequency. When F naught is equal to F in, we call it as phase lock state. Therefore, VCO has three states. One is free running, second one is capture state, third one is phase lock. Free running state. So in free running state, in the absence of input signal, VCO will produce or generate output waveform corresponding to the voltage available at pin number 5 of VCO. This state is called as free running state. Next is capture state. So when input is given, VCO output is compared with the input signal and so on. Error is produced, it is passed through low pass filter. VCO will now generate output signal corresponding to the error signal and frequency is shifted towards V in and this will go on happen. This procedure is called as, this state is called as capture state. Next is phase lock. When output frequency is equal to input frequency, we say that it is phase locked. Now let us see pin diagram of PLL IC 565. Negative supply is given to pin number 1, positive supply is given to pin number 10. It has two inputs, pin number 2 and pin number 3. From pin number 4, we get VCO output and input to phase detector is given to this particular pin 5. Sixth pin is reference output, seventh one is demodulation output. And for VCO, we required external capacitor which determines the frequency of oscillation of output waveform of VCO. Now, functional diagram of PLL. So we can see that in PLL, it consists of phase detector, amplifier, low pass filter, so capacitor, externally connected capacitor along with internal resistor forms a low pass filter, and then it has a VCO. We have seen its pin. So now VCO generates output signal depending upon timing resistor and timing capacitor as well as voltage available at the input terminal of VCO. The free running frequency of VCO, that is F0 or F out, is determined by 0.25 divided by CT into RT. 0.25 divided by CT into RT. So frequency is obtained as 0.25 upon CT when input voltage is 7 by 8 times of VCC. Now this signal is applied as input to phase detector. So we short pin number 4 and 5 so that this signal is available at phase detector. This signal is compared. Since only one input pin is used, let us now connect pin number 3 to ground. Phase detector will compare input signal and VCO output. It is amplified and low pass filtered, and then it is given as input to one stage. Output of VCO becomes equal to the frequency of achieved. Therefore, phase lock is achieved. Let us see application of PLL, FSK demodulator. FSK stands for frequency shift keying, whose frequency is shifted to either FH or FL depending upon whether a binary 1 or 0 is to be transmitted. The capacitor C2 is used to remove a block DC level present in the input signal. PLL will get locked to the input frequency. We have seen that VCO is present inside PLL. So VCO tracks the input frequency between two frequencies, FH and FL. Low pass filters are used to remove high frequency components present in the input frequency FH, which is higher than the free running frequency of VCO. The VCO control voltage produced is given by VC1 is equal to FH minus F0 divided by K, where K is voltage to frequency conversion factor. When input frequency is FL, the VCO control voltage is given by VC2 is equal to F0 minus FL divided by K. These voltages are compared with the external reference voltage to produce a digital data output. Thus, FSK is demodulated.